Hi everyone, and welcome to AP Daily. My name is Tim Gallagher, and I'm an AP Computer Science teacher from Winter Springs High School, located just outside of beautiful Orlando, Florida. And today we are going to be talking about topic 3.5, which is compound Boolean expressions. And this is the third of 3 videos on that topic. And today we're going to focus on something called short-circuited evaluation. So what will we learn? So again, we're still looking at evaluating compound Boolean expressions in our code. Like we've done in our previous videos in this topic, we are going to be using our logical operators, not, and or. We're going to be evaluating logical operators so that we can put an expression down to a single Boolean value. And today we're going to add in the idea of a logical expression can be determined sometimes by only looking at the first Boolean operand, and this is called short-circuited evaluation. So let's look at an example. So here's our party example from the last video. If you recall, going to a party, party has ice cream, party has cake, and this is an example of where I'm using the AND logical operator, and we said that in this case, in order for me to be truly happy and say that this is a great party, party has cake and party has ice cream has to be true. Well, in this case, as soon as I go to evaluate it, I go to check to see if the party has cake, right? So like if I'm at the party and I go up to the cake table and there's no cake there. So party has cake is false. But do I even have to bother checking for ice cream at that point? Because I know I need both and there's no cake. So at this point, I don't even care if there's ice cream or not. It's not going to change my mind about this being a great party or not. And I'm leaving, I'm not staying. So as soon as I determine that party has cake is false, I don't need to check the rest. Because party has cake is false, I don't need to check the second Boolean operand. I only need to check the first one. So it doesn't matter if there's ice cream or not. It doesn't matter if party has ice cream is true. It's going to immediately skip over the if and go to the else and print out I'm not staying. This is an example of something called short-circuited evaluation. It occurs when a compound Boolean expression does not have to be fully evaluated to know what my final result is. In the case that we just saw with the AND, the double ampersand, short-circuiting happens when the first half of the expression was false, the left-hand side, and then once that's false, there's no way for the entire expression to be true. It has to be false, so I don't even need to continue and look at the other half or the right-hand side of the Boolean expression. So can this happen with ORs as well? It's not going to be the same situation, but we can have short-circuiting with an OR. Let me show you an example there. So here, this is when we're a little less picky. I'm going to the party, and as long as it has cake or ice cream, then I'm going to say this is a great party. So imagine you walk up to the cake table, and there's cake. It's true. At that point, since I only needed ice cream or cake, I'm already determining that this is a great party. I don't need to even check for ice cream. Because party has cake is true, only the first Boolean operand has to be evaluated. I don't even need to check over at the ice cream table to see if there is any ice cream. I'm automatically going to now print, this is a great party. And I can ignore the party has ice cream, and then this is a great party gets printed out. So that's an example of short-circuiting with an OR. Why do we care? Well, here's how we can use short-circuiting to our advantage. Here's a program called score average. And in this case, I've got 2 variables. I've got a sum of scores, which is a double, and a number of scores, which is an integer. I set them both equal to 0. And this is a program where I'm going to try to calculate my average score after I have a sum of scores, and I'm going to divide them by the number of scores, which is how we calculate our average. And if that average happens to be greater than 80, well, then I want to print out you have a high average. Otherwise, I'm going to print out that you do not have a high average. Well, what happens if I don't have any scores or I forget to put the scores in? So my number of scores is still 0. I'm going to run into a problem here. This is going to divide by 0. My program's going to crash. I don't want that to happen. But will it? Because look at the first half of this expression. The first thing I check is to see if number of scores is greater than 0. If number of scores is not greater than 0, is it ever going to evaluate the second half? It won't, because there's an AND here, and short-circuiting is going to kick in. So in this case, number of scores greater than 0 is false. So it's not even going to bother checking the second half because it already knows this expression is false. and it's going to jump down to the else and print out you do not have a high average. So as a result of short-circuiting, it prevented a division by 0. And that's a great example of how you can use short-circuiting to your advantage in your everyday programming. So what should we take away from this? Well, over the past 3 videos, we've been looking at evaluating compound Boolean expressions in our program code. We've looked at logical operators, we've looked at expressions involving the logical operators, and then finally in this video, we looked at logical expressions with ands and ors and how we can use short-circuiting to only have to evaluate the first Boolean operand and not the second. That's it for today. Thank you so much for joining us at AP Daily, and we'll see you next time. Take care.